and you have a key, which is the value that you're trying to locate within the array. And you keep track of two variables, which are the lower and upper bounds of where you think that value could possibly be. Right now, it could be anywhere. And you look right in the middle of that range. What you find is too small, then the key has to be after that. You look in the middle of the range. What you find is too big, the key has to be before that, and you kind of keep subdividing your range until you narrow in on the value you're looking for. And in code, binary search looks like this. And from my perspective, you can't see anything here. You can't see anything. I see the word array, but I don't actually see an array. And so in order to write code like this, you have to imagine an array in your head. And you essentially have to play computer. You have to simulate in your head what each line of code would do on a computer. And to a large extent, the people that we consider to be skilled software engineers are just those people that are really good at playing computer. But if we're writing our code on a computer, why are we simulating what a computer would do in our head? Why doesn't the computer just do it and show us? So, let's write binary search. Function. Binary search takes a key and an array. And then over here on this side, it's saying, okay, it takes a key and an array, such as what? Give me an example. We need something to work with here. So, for instance, my array might be A, B, C, D, E, F. And let's say, for instance, we're looking for the D. So now let's start coding. The lower bound starts out at 0. Over here it says low equals 0, nothing amazing there. Upper bound starts out at the end of the array, so high equals array length minus 1. And over here, it says high equals 5. So I have my abstract formula in the code. Over here, it's giving me the concrete value corresponding to these example arguments. So I don't have to maintain this picture in my head. It's just showing it to me. So now I need the index in the middle of the array. So I'm going to take the average of those two. Mid equals low plus high over 2. And well, that's obviously not right. 2.5 is not a valid array index. So I guess I need to round this off. So I'm going to add the floor function, and it rounded down to 2. And I caught that bug literally the second I typed it, instead of writing the entire function in 20 unit tests. So now I get the value out of the array. And then I need to subdivide my range, so there's an if statement, which I'll just paste in here. So in this case, the value I found is less than the key, so it's taking this first branch of the if statement. It's adjusting the lower bound. Of course, if the key was smaller, then it would take this branch of the if statement and adjust the upper bound. Or if the key was C, then we would have just happened to find it on the first shot, and we'd return the index. So this is the first iteration of this algorithm. And now what we need to do is loop. We've subdivided the array. We need to keep subdividing until we narrow in on what we're looking for. So we need to loop. I will just loop. While 1, do all this. And now what we have are 3 columns corresponding to the 3 iterations of this loop. So this first column here is exactly what you saw before. Low and high span the entire array. We found a C. It was too low, so we adjust our lower bound. Loop up to here. Second iteration, bounds are tighter. We found an E. Adjust the upper bound. Third iteration, loop up to here. Low and high are the same. We've narrowed it down to a single candidate, is indeed the key we're looking for, and we return its index. So there's nothing hidden here. You see exactly what the algorithm is doing at every point. And I can go up to here and try different keys, so I can see how the algorithm behaves for these different input arguments. And by looking across this data, I can develop an intuition for how this algorithm works. So I'm trying different keys here, and say I try looking for a G. And this looks a little different. It's not actually returning. And the reason for this is I'm looking for a key which is not actually in the array. And the only way of breaking out of this loop is by finding the key. So it's kind of stuck here looping forever. So we can take a look at this and see what went wrong? Where's this algorithm going off the rails? These first few iterations look fine, but this iteration looks weird because low is greater than high, where our range is completely collapsed. So if we get to this point, then we know the key can't be found. So I see this faulty condition here. I say, oh, that's not right. Low has to be less than or equal to high. Okay, well, I'll just put that over as the condition of my while statement. Low less than or equal to high. And then that would break out of the loop, and I would return some sentinel to say that could be found. So here we have 3 iterations of the loop. Couldn't be found. We return the non-found value. So that's what it might be like to write an algorithm without a blindfold on. So I've got this principle, again, that creators need to be able to see what they're doing, that they need this immediate connection to what they're making. And I've tried to show this principle through 3 coding examples, but that's just because this is a software engineering conference. I thought I was supposed to talk about programming. But to me, this principle has nothing to do with programming in particular. It has to do with any type of creation. So I'd like to show you a couple more demos just to show you the breadth of what I have in mind here. So to begin with, let's take a look at a different branch of engineering.